Greetings, everybody. Welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. smAsho. Today we're talking about a coronal mass ejection watch, the situation going on beyond the universe. As well as galactic cluster Abell 3827. First, we're looking at a 48-hour video here from the SDO, the Solar Dynamics Observatory, of El Sol in 94 angstroms. To see some sunspots setting on the southwest and an active region rising in the southeast. No umbre visible, at least while we did show prep. Since there's a coronal mass ejection watch in effect, and we just had a coronal mass ejection on the far side of the sun, let's take a look at the viewpoint from Lagrange point 5, the location of stereo A. And here's what's going on recently at Lagrange point 5. Note the time and date stamps. Yesterday we saw a significant far side of the sun coronal mass ejection. And for you new viewers out there, the Earth would be off in this direction from the perspective of stereo A. Again, that is located at Lagrangian point 5. So here you can see this significant coronal mass ejection. Originally starting to blast off around 1 o'clock universal time yesterday. And the likelihood of this filament to eject in the Earth-facing region is nearly 100%. So we're expecting another coronal mass ejection, more in the Earth-facing vicinity. Let's take a look at the one we saw yesterday from Lagrange point 1. Here's the LASCO C2. Again, Lagrange point 1 located between the sun and the Earth. And here's the initial blast of that coronal mass ejection. On the opposite side of the sun from the Earth. And expected to go east of even stereo A, as we saw in the previous animation. So that's that coronal mass ejection. Here's a one-day video in 171 angstroms. Again, no apparent sunspots currently. There is another small active region right here. Also does not have any umbra. And let's do a 304 angstroms ionized helium one-day video. And the filaments that we're expecting to see eject within the next, I'll say 12 hours at this point, are all down in this area here. So a bunch of filaments there. We'll be watching for those to eject later today. Something to keep an eye on. And when I say eye on, well, the pun is intentional. Let's blast through a whole bunch more information here. Such as the location of planets. Here's a diagram of the solar system. There's where we'll be in a week. It looks like 8 days until the next new moon. Here's a star chart. The sun will be traveling through Aquarius, Capricorn, Sagittarius, Scorpio, and Libra. Also, the moon is out there. If you're up before dawn, you may see Saturn, Jupiter, and the moon near the ecliptic, which is this yellow line, the path the sun takes across the sky. The radio flux of the 2800 megahertz variety, otherwise known as the 10.7 centimeter radio flux, the F107, is at 72 solar flux units. Here's a one-year chart of that. The black line is the radio flux, and you can see the proportionality between it and the sunspot number, which has dropped all the way back down to 0. NOAA expecting additional periods of geomagnetic unrest, a KP of 4 forecasted here, which we never actually saw today, and one brief period of geomagnetic unrest forecasted for tomorrow as well. According to NOAA, it's because of an ongoing coronal hole wind stream regime, and earthquakes of the past 24 included this one, which happened as we did show prep in northern Mongolia. A 5.6 magnitude quake, the largest of the past 24. Let's check the rest of the list here. We saw a deep quake near Tonga, the deep quake capital of the world. Also a deep quake in the Banda Sea. Those both in the mid-4 magnitude range. Also a deep quake at Vanuatu, a 4.7 at 220 kilometers depth. There was another 5.6 in the past 24 as well. That one was at Indonesia. Nearly at the same longitude as that 5.6 magnitude quake in Mongolia. And I'm just going to let the list scroll here. If you see anything of note that we missed, just leave us a comment. Fiji also saw a nearly 600 kilometer deep 4.4, and Japan saw a nearly 200 kilometer deep 5.5. And those all came through rather recently there. The 5.5 at Japan was at 5:07 Universal Time on May 3rd. So a series of deep quakes there. No major quakes. And check out the lava fountaining we saw at Fagradalsfjall. The largest lava fountaining events that we've seen during this eruption of the Icelandic volcano. Reaching about 1,000 feet of altitude, these are estimated to be about 300 meters. The altitude of the height of those lava fountains. So two different events happened here. There's one. Here's the second. The most significant lava fountaining events of the 2021 eruption of the Icelandic volcano Fagradalsfjall. And we see an uptick in volcanoes basically worldwide. So lots of volcanoes currently erupting. Also including Sakurajima, which is exploding, 6,000-foot ash plume there over the Japanese volcano. Suwanosejima, flight level 090, it's a 9,000-foot ash plume. Ibu exploding. In Indonesia, 6,000-foot ash plume. Dakono exploding, 7,000-foot ash plume. Popocatépetl exploding, 19,000-foot ash plume. Fuego exploding, 14,000-foot ash plume over Guatemala. The Ecuadorian volcano Revenador exploding, 15,000-foot ash plume there, and Sabancaya exploding, reminding us not to pole vault the caldera. The strong puff of volcanic ash during this explosion was enough to produce a 27,000-foot plume of ash. And since people are stupid, here at smAsho.com, we would remind folks to not pole vault the caldera. If you'd like some gear, some merch with the Do Not Pole Vault the Caldera extremely high-resolution imagery on it, head to smAsho.com. You'll find a link there for smAsho merch. It makes a great Mother's Day present. Next, the GOES X-ray flux. And we saw a nearly B-class flare there, so very low levels of solar activity. Again, 0 sunspots is the current number. No strikes in the proton flux there, as no coronal mass ejections have been Earth-directed anytime recently. Here's the GOES magnetometer over the past 3 days. And we are in the process of switching to the other polarity current sheet. Why did the proton cross the solar system? To get to the other current sheet. And here's a visualization of that. The top view ecliptic plane field plot, and Earth is probably already in the South Pole-oriented current sheet shown here in red, snapping across from the green current sheet shown in blue, associated with the north solar polar field, the red current sheet associated with the south solar polar field. This data is derived from ground-based magnetometers on Earth, about 51 of them, as well as magnetometers on stereo A located there, and stereo B located there. Here's a line-of-sight ecliptic plane field plot, a three-dimensional image of the essentially same data. North Pole polarity likely already here. Here's the line-of-sight coronal hole plot. And the coronal holes are looking weak, folks. They're looking diffuse. And the 193 angstroms imagery agrees. Here is the detected coronal holes imagery from the Integrated Space Weather Analysis Center. Looking diffuse. KP index has only made it to 3 over the past 3 days. Current condition is KP of 2. It's a measurement of global geomagnetism. Next, looking at the real-time solar wind. To see the coronal hole wind stream finally kicking up to high speed. So as we did show prep, we saw the coronal hole winds, the solar wind speed rather, from this coronal hole wind stream make it up to about 450 kilometers per second. Current conditions are more like 421 kilometers per second. Solar wind density around 5 protons per cubic centimeter. And we're expecting this to continue for at least about 24 hours. Here's a geospace magnetosphere movie. I think. It's 4 hours of data of magnetohydrodynamic pressure. And we're expecting to see an uptick here in the second half of this video here, showing the uptick in the solar wind speed. So we can expect the pressure to increase here right toward the end of this video. It's 4 hours of data. Not so much of a signal there. Next, looking at ground magnetic perturbations, geospace delta B changes in the Earth's B field. We show it daily due to the fact that there is a polar excursion currently occurring, where the planet has 2 geomagnetic north poles. The geomagnetic south pole somewhere south of Australia. And this is measured in nanotesla. The Space Weather Modeling Framework. Thanks to our BitChute subscribers, we've recently reached 420. Thanks to our Twitch subscribers. And let's actually welcome our Twitch viewers. Welcome to our Twitch viewers. We've decided to go live for the cosmology segment. Twitch.tv/smAsho is the URL. It's a fantastic mobile live streaming platform, rather. Again, thanks to our followers over there. Also, don't forget to check us out on Instagram. Still not even at 500 followers over on Instagram, despite having over 3,000 posts. You may not see yesterday's bike ride if you don't head to instagram.com/smAshomash. And thanks to our subscribers over on YouTube. If you're viewing YouTube, don't forget to press like and subscribe. Thanks for your continued support. Leave us a comment. Press the share button. Share the content on your social media. Today's cosmology segment will be fairly short. Today's astronomy photo of the day is from Apollo 11 by Michael Collins, who was the only person not in front of the camera on this image as the lunar module returned to the lunar orbiter and command module. So you've got most of the people on the planet were there. There was one here and one in the lunar module. Every person but one was in front of the camera. This image from July 21st, 1969, as the lunar module reunites with the lunar orbiter and command module. Let's talk about Abell 3827, a massive galactic cluster, an X-ray source and source of gravitational lensing, featuring hundreds of galaxies, all clustered together. And here's an article about it on SciTechDaily.com. Hubble using 2 different cameras to take some close-up imagery of Abell 3827. I'll let the article scroll in case you'd like to read. Again, that is on SciTech Daily. And I would note, galaxies were not always believed in. So the possibility of other galaxies had been debated previously, but the matter was not truly settled until Edwin Hubble confirmed that the Great Andromeda Nebula was in fact far too distant to be part of the Milky Way, and the Great Andromeda Nebula became the Andromeda Galaxy. As astronomers recognized that our universe was much, much bigger than humanity had imagined, we can only imagine how Edwin Hubble, after whom the Hubble Space Telescope was named, would have felt if he would have seen this spectacular image of Abell 3827. If you want to look at Abell 3827 some more, head to Aladdin Light, type in Abell 3827. There it is in X-ray, and you can see it's a very bright X-ray region there, located quite distant. That is the X-ray imagery from the Chandra, and I would note how differently it looks in blue light. And here is this gravitational lens feature, or I'll just say lens feature, of Abell 3827, which brings us to another point. Is there anything beyond the universe? Well, in short, the answer is that it's complicated, folks. It's complicated. So if you think of the universe as a ball inside of something else, what is that? Is it inside of, is it a bubble? Is it a series of soap bubbles inside of other soap bubbles? Or is it perhaps just an infinite space, in which case the universe is not contained by anything? It's a bit of a tough one to wrap your head around. So here's an article on space.com about this. Allow me to get off screen and let the article scroll. And so the first thing you have to ask yourself is, what's outside the universe? Is what do we mean by universe? Does it mean literally all things that exist and could possibly exist in all space and time, in which case there could be nothing outside the universe? Or is it perhaps a universe within universes within universes? Ultimately, the answer we don't know. The current width of the observable universe is about 90 billion light years. And what's outside of that? Is it just more of an expanse of more stars and galaxies? Well, the answer is we don't know. We can only see so far. And is it flat? Is it curved? Perhaps read the article on space.com about what's outside the universe. What do you think? Let us know in the comments. And that's today's Cosmology segment. We'll say goodbye to Twitch, and we'll bring you back for the meteorology segment. Continuing on with the daily space weather, the Smash News Network will next be looking at the electron flux. Here's a one-year chart of it. We're at fairly low levels now, as a coronal hole wind stream has arrived in a fairly weak and non-exciting fashion. Here's a 3-day chart of the electron flux, and you can see the typical cratered electron flux during the time of the coronal hole wind stream, despite it being a weak coronal hole wind stream. So we don't see very many charging hazards here. No surprise there. Some minor surface charging hazards over Central America and Mexico and the Central Pacific. Here's the electron forecast model. And NOAA forecasting this green box flat electron flux for tomorrow. Here's a diagram of the Earth's Van Allen belts. Feel free to pause the video if you must. Here's a visualization of the total electron content. And we see fairly chaotic electron belts here. These blobs of electrons are blobs through which your GPS handset and a GPS satellite must communicate, and they cause GPS errors, and we see chaotic jet streams. I'll let it play through a second time. These chaotic jet streams are typical of the influx of a coronal hole wind stream. We see more orderly electron belts when the electron flux is at a little higher levels. And of course, GPS errors are most likely to occur around the equator at noontime. Although during these coronal hole wind streams, you can expect GPS errors all around the equator all day long. Here's another diagram of the atmosphere. It's showing you the F ionosphere layer. We show it daily. The F layer is what we're showing next. It's the F ionosphere map. And we're seeing a bit of anomalous activity in the ionosphere as well. Not too surprising to see anomalies in the electron flux, the total electron content, and the ionosphere coming at the same time. We see a very wide band of nighttime low frequency. And a bit of a wobbly sun-facing portion of the ionosphere as well. And let's bring up the latest image. The latest image coming through here at 9:45 Universal Time, looking fairly normal there. And it's time for a quick meteorology segment. So let's bring back Twitch. Welcome back, Twitch. Twitch.tv/smAsho. Today's meteorology segment starts out with looking at the jet stream. And look at this S-shaped bend in the jet stream down here. Two 180-degree bends here south of Australia. By the way, the Earth's south geomagnetic pole is someplace around here. And we'll look at the surface winds as well. There are the surface winds of the eastern world. Surface winds of the western world are next. Some very strong winds at the southern tip of Greenland, actually. And here are the jet streams of the west. Quite chaotic on this side of the planet as well. Next, looking at lightning, and we see quite a bit of lightning here on a global scale. Some in West Africa, some in the U.S. Let's check out the terrestrial lightning in the U.S. Hey, Atlanta. There's no thunder rolling in. Although Nashville has seen some fresh lightning strikes just south of it. Anyway, there's the lightningmaps.org scenario for lightning. It's a real-time lightning map, lightningmaps.org. And here's the NASA GOES lightning mapper. Showing you the last 5 hours. Long string of lightning stretching all the way from Kansas to Wisconsin here, as well as heavy lightning over southern Mississippi, Alabama, western Tennessee. And so we see the entire central portion of the country here in the U.S. totally encased in low pressure and some turbulent weather indeed. Let's advance this into tomorrow. Here's the Euro forecast, actually, for pressure at 1 p.m. tomorrow Eastern Time. And we've gone to tropical tidbits now to show a forecast map. So here's the precipitation rate. We're seeing additional snowfall happening here in Wyoming and Colorado. Despite all that hot air coming out of Colorado, snow continues to fall. And so we're expecting some heavy storms here over central Wisconsin, northern Arkansas, and then southern Illinois, eastern Missouri, northeastern Arkansas, western Kentucky, western Tennessee. So that's how that's expected to play out there, folks. That's the Tropical Tidbits GFS forecast. Some very heavy storms forecasted for the Illinois, Missouri, Kentucky border region. Here's the current U.S. Doppler radar map. Note the time and date stamps. Snow also falling in Montana and Idaho and Utah. Here's what's going on in the cloud layer. Got this long string of clouds here stretching from the Yucatan Peninsula to Florida. Also a bunch of low clouds once again here over the North Atlantic. Here's a water vapor map. There's the cloud layer. Again, there's the U.S. Doppler radar. I would note one thing that's very obvious here in the cloud layer and the water vapor map. This powerful low pressure here. It's moving quite steadily to the northeast. And we're expecting it to largely continue that path at least for the next 24 hours or so. One last time, there's the U.S. Doppler radar map. Here's the cloud layer. And here is the water vapor. And that's today's meteorology segment. We'll have to say goodbye to Twitch. Bye, Twitch. And let's get into bonus features for the daily space weather. Here's the latest imagery from El Teide, Spain, ground-based solar observatory. Again, folks, don't be surprised to see these filaments in the southern hemisphere of the sun to eject today. Likelihood is very high, nearly 100%. Next, I'd like to thank our patrons, the true source of funding for the content. If you want the videos early and all kinds of other alerts that nobody else gets, consider becoming a patron. Open your cobweb-encrusted wallet and send us $3 a month to get the earliest information that nobody else gets to see. Here's the active region. And again, when I did show prep, we did not see any umbre associated with it. There is the intensity gram. You can see no dark spots. Here's the colorized magnetogram. Not looking like a sunspot. Here's the setting regions in the southwestern hemisphere. I thought I had it on loop. It's sunspot 2818, 2820, and 2821. And last but not least, here is the rising active region. Filamentary dance going on to the south of it as well. Right down here. Bunch of filaments there in ionized iron. Anyway, thanks for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. We'll assist you with that. Welcome to the Neo-Renaissance, and since it'll never be now again, may that solar wind be at your back.